Hi everybody, this is the class number 6 of the track 4 of how to apply artificial intelligence techniques to the context of the container port logistic operations. So this video will be very interesting and important because we define the last operator that's necessary to build the genetic algorithm, which is the mutation function. So what is the mutation function? It's just to pick one individual and change its values at handle. We select some at handle some elements of the individual and change at handle. It's just this. So let's start code the mutation function. So as I said, what is necessary here? I will make this much simple as I can. So let's suppose that we have this list which has some integer numbers. And what is most important here? We have a print, and this print will be before. Oops, I don't know what's happening here. Bit string before mutation. We got here. So we print bit string, and also we got this after mutation. It's just before nor before. It's very strange. So mutation. Oh, it's not good. This bit mutated. It's much better than this. So what we should return? We should return this bit string mutated, and we should define mutation function bit string, and finally we have some bounds. And as I said before, this will be very simple. Just to understand, these are the bounds since we're gonna use this to create randomly, okay, the things. So this is the mutation. Uh, this mutation could be as a property of the just a field of the class or a parameter of this mutation function. So we just fixed here the rate of mutation, and finally we have here how many elements of this bit string will be mutated. We're gonna search all elements of this bit string, but we can change it if the we pass on this. So if this random value, this is a random value, okay? So if you want to use this command, you need to employ this. So this mutation, it will happen if we try to generate at handle some number, and if its number is lower than this mutation rate, we can flip this tree, the bit tree. Okay, we can change a specific element that we are uh, uh, looking for. For example, this, and we can change for randomly, including we can change to the initial value. So we can change, but not okay. Sometimes it will not change. It will change nothing because it can remain the same value. But it's random. It's not for sure. So here we have the bounds. Okay. So we need to define the bounds. Bounds are defined here. It's not good. Okay. I know this, but the bounds are defined as a field in the class. So when we build the class, this will not be here. This will be defined in a very different way. It's just perform some tests. And I know that's missing something. You know that I'm not returning anything because in the case of a list, if you change something in the list, the list will automatically return this change. Okay. So let's see what's happening here. Render int is not defined. It's true. We need to define also render int because if we are trying to use render int, so I need also remember that render int is just another command that we can create. So here we have this bit is not changed, this had changed, and this is the change, and these ones remain the same. So it's just to create a little disturbance in certain parts of an individual. This is why we employ this mutation operator, okay, in genetic algorithms, just to make some little different individuals and see if these little different individuals produce a better quality solution. If not, you can remain, you can stay with the best individual. As we can see in the complete code, I will show you the complete code in the next class. So I hope you find this video interesting and useful, and see you in the next class, which will be the last class of this track. Remember that we're gonna use a different approach in the next class. We're gonna show all the code and see, oh, this part, we already talked about this part in the class number. No, no, no. And so it will be a very, very interesting approach since we have detail all things, make very detailed experiments to explain all the code, and the approach will be different in the next video. So see you in the next video. Bye.